Stop singing. Okay, class. Class. Thank you. Someone knows it. Class. Stop singing. Thank you. I need for you to draw your attention to the board and get ready so your extracurricular talking is over. It's over. If that is Shane, zip it.
What's her name?
Shane.
Shane. What that mean? This is her name. Oh, no, don't worry about it.
Hey, Miss Adams, I need your YouTube channel so I can go subscribe.
Okay. Can you get into Schoology?
I haven't been in there yet because my mom don't know my password or anything. I haven't gotten there yet.
You haven't gotten there yet. Okay. Okay. I will send me a text of everything you need, Miss Darby number and the YouTube channel address, okay? And some
Yes,
point today, I'm going to send that to you.
Yes, ma'am.
I'm not gonna send it to him tomorrow. I'm gonna send it to him today, at some point today. We're on quite early today, so that's fine. Getting everything together and situated. Make sure if you have your textbook that you have your textbook and you're on lesson 3, chapter 1. For those people that don't know how to find lesson 3, chapter 1, page 23. Page 23, we are taking notes today. We're going to highlight some things and we're going to circle some things and underline some things. Okay. I'm about to share my screen. And with me sharing my screen, I want you to pay attention to the sheet that is attached to my screen shared. There it is. Okay. Huh?
My science notebook at school.
Okay, you're gonna have to write on some paper, okay?
Yes, ma'am.
No, never mind. Never mind. When are you coming back or you just went virtual?
I'm just in a virtual.
Just went virtual?
Yes, ma'am.
Huh?
I don't know when I'm coming back. I might ask my mom, can I come back probably next week?
Okay, I just need to know, but I was gonna suggest something, but okay, that's all good. We're good. Okay, so this is the sheet you should see. Virtual, you don't have to have this sheet. You just need to pay attention. Okay. So we talked about solids, liquids, and gas, the states of matter. We talked about this the first 9 weeks, right? Talk with me, because I don't want to feel like I was lost. So somebody give me an example of a solid.
Something that's hard.
Something's hard, a rock. Something frozen. Okay. Can somebody give me an example of some liquid? Water, drink, soda, huh?
Water. Right.
Water, very good. Can somebody give me an example of some gas? No. Air, very good. No, what's in the balloon?
Air.
No. Helium, very good. Helium, very good. So remember when we talked about particles?
Oxygen.
Oxygen is gas, very good. We talked about particles. Y'all remember we talked about particles? Yeah. And
yes,
we said solid particles. What's the shape of a particle? A what? A circle. Very good. A shape of is a circle. Someone's making an awful noise and you may want not to do that or your feelings may be hurt. I'm just saying. Okay, so it's just a dot, a circle. Particles in a solid, how are they? A solid. Now think about a solid. They what? Close together. Do the particles move or they just stand still? They what? They move. Yes, particles move. They do what's called a what? Start with a V. What you say? Vibration. Very good. Someone Miss Darby room. It's a vibration. Particles always moving. They're always moving. So when they're in a solid, they're what? They're not froze. Well, they could be froze, but still vibrating. They are close together. So what I want you to do on your paper, I want you to do dots. Show me the particles of a solid on your paper. Where it says solid, down here and here, show me what the particles will look like. What would the particles look like in a solid? If I was drawing a particle, filling this up with particles, I'm filling this up with particles. What would it look like? These are my particles of a solid. All right. We're not going to fill it up. We're just going to do a little of it, okay? Because we have to move on. But we're going to see the gist of what the solids, the particles of a solid looks like. We're going to see the gist of it because I feel we don't need to go through this. Okay, that's the gist of what the solids or particles of a solid look like. Okay? You can't see what? You need to move so you can see. I keep telling you that. Because I don't do excuses if I can't see once you can get your behind up and move somewhere else. Yes, sure. Okay. Does a solid have a definite shape and definite volume? No, it doesn't have a definite shape or a definite volume. I'm asking. Don't look at me because I ask questions. I just ask.
No.
It has a definite shape and a definite volume. Yes, a solid has a definite shape and a definite volume. So if you got space up here, write definite DFINIT, definite shape and volume. Definite shape and a definite volume.
What
Yes,
you know?
sweetheart. Okay, liquid. How's the particles in a liquid?
They all together, but
They're what?
they're moving around.
They're moving around. Very good. But how are they moving around? They vibrating, but I'm saying, but how are they moving around? Are they scattered wide or close? They're close. Very good, guys. Very good. They're close. So basically, I can say this is my particles of my water. They're close. All right. So does a liquid, does it have a definite shape and a definite volume?
Oh.
What does it have? It has a definite volume, but not a what? Exactly. It takes the shape of it, whatever its container is. So it has a definite volume, but not shape. But not a definite shape. Okay. Y'all got it? Y'all got it? Okay, let me know if I need to slow down. I'm glad because I want.
I got it.
Great job. All right, can I move on?
Yes, ma'am.
Okay. What about gas? How you think the particles are in gas? They're spaced out. They are. Gas are spaced out. So they like ping, 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 ping. And everywhere. Gas particles are everywhere. So do they have a definite volume and a definite shape?
No.
No, they don't. They do not have a definite volume or a definite shape. No definite volume or
I can see you.
there you go. No definite volume or shape. None whatsoever. Okay. All right. Hello. And particles are always what? Moving. Remember that. Particles are always moving. Particles are always moving. Okay, so now we finna do a little something real quick. I don't know what time it is yet. We're gonna do it real quick. We finna highlight our book. Get your book out. Freezing and melting. Freezing and melting. I'm just gonna tell you what to do. When we freeze and melt, liquids get colder, their particles slow down. As liquids get colder, their particles do what? I'm on page 25.
Slow down.
Slow down. Liquids get colder, particles slow down. Look what I just did. I told you had your science book out. You should have been on 23, turning over to 25. Who doesn't have a science book? I don't know why you would not have a science book, India Watson, because when I made a math book, I made a science book. Yeah. You better find it, because I sure made you one. You can see one over there on that wall for you. All right, here we go. At some point, they stop gliding past each other. I'm sorry. Am I boring you? Am I boring you? I'm sorry. You're supposed to be paying attention. Maybe I need to enlarge it so you can see. You can see now. Can you see better?
Yes, ma'am.
Okay. And at some point they stop gliding past each other, but they only vibrate in place. Liquid becomes a solid. Liquid can become a solid. I'm skipping down because it says the temperature at which material changes between solid and liquid states has two names. Temperature, as I highlight, you highlight, at which a material changes between solid and liquid states. One is called the freezing point, when a liquid turns into a solid. The second is called the melting point, when a solid turns into a liquid. Melting point and freezing point are the same temperature. Y'all got it? No, because I'm about to turn the page.
No, ma'am.
Let's highlight real quick. Temperature at which material change between a solid and liquid states two names. Freezing point, melting point. The freezing point is when a liquid turns into a solid. The melting point is when a solid turns into a liquid. And the melting point and the freezing point is the same temperature. These are your notes. Remember last week you had a test and you had to use your notes? Same what happened when we get ready to test this. All right, moving on. No? Are you saying no? Are y'all really paying attention and highlighting? Because my class have highlighters. So you shouldn't highlight when I highlight. But if you over there talking, I'm gonna stop waiting on you.
I got it.
Thank you. Because this is enough time that the ones in virtual could write this down faster than you highlighting, stroking a marker across the page. Time ticking, people. I gotta move. Evaporation. Who knows about evaporation? Heard the word evaporation before? All I need you to know for evaporation is evaporation takes place when particles leave a liquid and becomes a gas. Gas particles move quickly upward through the liquid. Bubbles of gas form under the surface of the liquid. That's evaporation. When you boil in a pot or when your mom is boiling a pot of water and you see them bubbles coming up, that's evaporation. The steam is gas. It's cooking, yes. It's heating up the water particles. And so the particles are boiling and it's turning into gas and it's causing evaporation, okay? The gas particles are moving quickly upward, not downward, but upward through a liquid, okay? That's what I need you to know about evaporation. Flip condensation. If I go too fast, you can come borrow my book or you can check YouTube and you can pause YouTube. Condensation. I'm highlighting. Condensation occurs when a gas turns into a liquid. This process often occurs when gas particles touch a cold surface and the temperature of the gas drops. Such as when you wake up in the morning. Oh, how many woke up this morning and they rode to school and they saw that it was kind of icy on the car?
Me, my brother.
That was condensation. You wake up in the morning, you see the grass is wet in the morning. How many see that? Yes, Brianna, Zai, Hernandez, very good. See the hands in Miss Darby's room? That's condensation. The rain dew or the dew drops on the grass is condensation. That's where the gas particles touch a cold surface. What was the surface?
The car.
The grass or the car. The grass of the car. It touched the cold surface and the temperature of the gas dropped and it formulated a crystal. Those are like little crystals, okay? That's condensation of water vapor. There you go. Y'all got it? You got it?
Yes. Yes, ma'am. I got it wrote down.
Very, very good. Now, I'm going to ask you a question. I'm going to show you something. All right. I'm going to show you something. Pay attention to the screen. What's the difference
It's flowing. The bubbles popping.
What's the difference between the two cups?
One of them.
One is solid, one is liquid.
What's solid and one liquid?
One's a solid, one's a liquid. That's what y'all say, right?
Yes, ma'am.
Okay, very good. I didn't say you took wrong. Very good. Okay. So can you tell me the difference between a mixture and a solution? Okay, Miss Darby, if you can check your volume on something,
Miss Darby, turn your
because it's giving reverb and it's really hurting. If you could tell me the difference between a mixture and a solution. What's a mixture? Anybody know what a mixture is? Anybody? Okay. What's a solution? Okay. What I just
Bonded two things together.
binding two things together. Yes, that's a solution. A mixture, if you turn to page 29, a mixture is different materials that are placed together, but y'all see that? Page 29, different materials are placed together, but each material in the mixture keeps its own properties. Each keeps its own properties. So which is a mixture? Is this a mixture or is this a mixture?
The one that has
This is a mixture of tiles. These are different tiles. So you can see what this is. This is a mixture of different tiles. All kinds. So is the water solution?
No, ma'am.
If this is a mixture, what is the water? If this is a mixture, if this is the mixture, what is, you said water is the solution? No,
Yes.
it's not.
It's liquid.
It's liquid. Yes, it is. It's liquid, but it's not a solution. We don't do that on camera.
I mean,
It's one thing.
Go to page 32.
Okay.
32. Now it says a mixture in which substances are spread out evenly and will not settle is called a solution. Underline, highlight that. A mixture in which substances are spread out evenly and will not settle is called a solution. You will not see my paper because I am teaching 5th grade and I said go to page 32 and I'm reading directly from the book. You have eye coordination. Let's use it. I will repeat myself, yes. I said page 32. A mixture in which substances are spread out evenly and will not settle is called a solution. Watch what I do to the water. I'm putting a tablet in.
It makes bubbles. What is that? It makes condensation.
What's them bubbles called?
Condensation.
It's gas. Very good. It's gas. They're shooting out. They're shooting out. The particles are going everywhere because it's gas. They're bubbling up. Oh, look, it just got white like the snow. Y'all see that? You can barely see it now. You can barely see it. Now look what happened. You see what's happening? The gas is diminishing, right?
Yeah.
You see the gas is diminishing. It's settling down. It's settling down. But guess what? It mixed with the water. It spread it evenly across. Did it go in one little spot and stay there? Did it?
No.
It went across the whole bowl, right? So that's a solution. That's a solution. I'll tell you about it later. Depends on which flavor you get. Okay. All right, so I'm moving that and I'm bringing back my book. Bringing back my book. All right, so solutions. This is what I need you to know. The substance that is dissolved is called the solute. The solute. This is what was dissolved. What's that?
Oh, whose pack is that?
What is it? Read the title.
Alka-Seltzer.
Alka-Seltzer. This is an Alka-Seltzer Plus. This is a cold medicine. These are effervescent tablets that when you put in water, they turn into gas and you drink the gas to make yourself feel better. This is the solute. The substance in which the solute is being dissolved is called the solvent. So what was the substance that was being dissolved? What was the I want you to tie it into what you just saw. What was the substance that which was being dissolved? It was the water. The water. The water is the solvent. The water is the solvent. How many make Kool-Aid? How many people make Kool-Aid? With the powder, yeah, with the little powder stuff and the sugar and the water. Okay, sugar and water. The solute is the sugar. So the Kool-Aid and the sugar is the solute. And the solvent is the water. The water is the solvent. And water is sometimes called a universal solvent because it can dissolve many substances. Are y'all highlighting as I read that or underlining as I read that? Question?
Do you remember that thing that about the first day that was in Kool-Aid?
Uh-huh.
I drank
Well, you still using a solute and a solvent because you put it in water, right? Yes, even when you do those, what they're called when you put them in your water, the Crystal Light packets or the Hawaiian Punch packets, Kool-Aid packets, yeah, that's still a solute and a solvent. Yes, ma'am. Yes, those are your particles. Those your positive, mean your solids turning. And that's when we come down here. See what it says solutions of a solid in a liquid? You said your Kool-Aid packet is a solid dissolves. Individual particles separate from the solid and spread evenly throughout the liquid. Solids dissolve in a liquid faster by what? Stirring it or heating the solution. Or you can grind it and that also helps it dissolve faster. Gentlemen, you lost your PE for tomorrow since all four of y'all want to decide to talk when I'm teaching. Because I've asked you to stop talking and you still want to keep doing. You should be highlighting. Solids dissolve faster. How can solids dissolve faster? Give me a way. Give me a way how a solid can dissolve faster in liquids. Zakiria?
Pouring it out.
Not pouring it out.
If the
Pouring it
liquid
out
is
is
hot,
huh?
if the liquid is hot,
That's if the liquid is hot, you're still not pouring it out. You're heating the solution. Very good. How else can you make a solid dissolve fast? How can you make a solid dissolve fast? Alan? What I told y'all this week and last week, when I'm giving notes, I ask you a question. It's in your face. It's in your face. So it's not the teacher's fault. By stirring. That's another way. Heating the solution stirring the solution, or grinding it. Oh, now we catching on, okay? Keep catching on though, okay? What is water? What is water called?
Universal chain. Universal.
Liquid.
What is water called?
Liquid.
That is not on
Universal
my
solvent.
page. It's a solvent. Thank you, whoever said it. Thank you. A liquid is a water is a solvent. And water is sometimes called what?
Universal solid.
Yes, a universal solvent. It's not. Do you see H2O anywhere on this page? Do not say something that you do not see. Yes, water is considered H2O in the atom world. Yes, atom. It has H, 2 parts of what is it? Hydrogen and oxygen, 2 parts of hydrogen, 1 part oxygen. Think that's how I go? H2O, yes. But on this page, I'm trying to let you connect to your notes. So I think connecting your notes tonight would be good for you to write your notes 5 times each in your science note, but maybe you'll connect then. What's a solute? Can somebody tell me what's a solute?
It's substance that is dissolved.
Yes, a substance that is dissolved. Give me an example. What's a substance that's dissolved? Say it, Zakiria.
Crystal. Like
Crystal light, sugar, Kool-Aid, sand, but not sand. Sand does not dissolve. Sand does not dissolve. Salt, it kind of dissolve, but you got to stir it, so I guess it make faster. So yes, salt. Flour, yes, the Alka-Seltzer, yes. So what's the difference between a solution and a mixture? Look in your notes. What's the difference between a solution and a mixture?
A mixture spread out evenly.
A mixture spreads out evenly. What's a solution?
It dissolve is called a solute.
Nope, that ain't it. That's called a solution. A mixture is something that has different particles, different materials. This is a mixture, but everybody has the same properties. This property stays the same even when I add it into there. Do you see that?
Yes,
This
ma'am.
property, I'm gonna start teaching everybody else besides y'all. Y'all just do y'all at PE time. This property, these 2 properties stay the same even when I mix it in. Y'all see that?
Yes, ma'am.
That's a mixture where the properties are the same. I can sort these out. I can sort these I can sort this out. Can I not sort this out?
you can.
Hello?
Yes, ma'am.
I can, yes. I can sort out a mixture. I can sort out a mixture based on its physical properties. I can separate it based on its physical properties. Like this one is red. I can sort them out based on the red, the color, all the
shape.
reds. And then I can do all the
Green.
yellows. And I can do all the greens. A mixture, so basically a mixture you can separate. Everybody say mixture separate.
Mixture separate.
Yes, mixture separate. But I can't put with water on my book. Here's my solution. Here's my solution. Here's my, look at all that gas, yes. Here's my solution. And look. Now I have my solvent and I have my solute. I sure did. That's because they paid no attention. They're talking about I got a PE on Thursday.
Oh,
How what? I'm not doing anything. That's what it does. It's dissolving. It's dissolving. Can I separate this?
No.
Can I
Yeah.
separate it?
Yeah.
I can?
No.
Somebody said I could. Can I separate this?
No.
I can't, it's mixed in evenly, right? So I can't go in and pick out the Alka-Seltzer tablet anymore because the Alka-Seltzer tablet is what? Dissolved. It's turned, it flavored the liquid.
It's
It can flavor the, it flavored the liquid. And you would drink this if you were sick. But can I sort this out? Can I separate that?
Yes.
Yes, I can separate that. I can separate by colors. I can separate by size.
Shade.
Shape. Very good. Good job. By shape. I can separate by weight. Oh, is this not the same thing we learned yesterday by separating physical properties? We separate by color. We separate by temperature, by texture, by weight, the mass. And what's the other one? Is there another one?
No.
Yes, it is. It was 5. It was 5 of them. Color, volume, volume. Yes, it was 5 of them. Okay. Are there any questions?
No, ma'am.
Are there any questions? Hello?
No, ma'am.
Okay, your homework tonight is to take your notes that were in your book and you are to write your notes out in your notebook. You are to take your notes that we highlighted in the book and you are to write them in your notebook. Yes, take it home and bring it back. If you don't bring it back, you're gonna be missing, you're gonna be short. So virtual, I would take a picture of this. I'm gonna take a picture and I'm gonna upload it for you so you can write down your notes. So you can have your notes. Is that good? Thumbs up if that's good.
Yes, ma'am. Oh,
Job. Great job. Great job, Cody. Thank you. Great job, Holland. Thank you. Thank you, William. Thank you, thank you, thank you.
yes, ma'am.
All right. Thank you, thank you, thank you. I'm going to take a picture of each page that I highlighted. I'm going to send it to you guys. I'm going to upload it so you guys can see it. Homework tonight is to copy your notes. Thursday, Friday, maybe a pop quiz. Maybe a pop quiz. Maybe a pop quiz. Or I just may give you an assignment and we don't have to go virtual. However, any questions for me?
No, ma'am.
Isaiah, do you have any questions for me?
No, ma'am.
I'm gonna go back on YouTube and copy all that.
Okay, baby. Thank you so much. I really appreciate you. This is hard. Remember Thursday night, 50 points. If your parent come to parent conference, not parent conference, but parent meeting, 50 points, 6 o'clock is going down. Use my YouTube code.
Miss Abby,
I won't be late. Yes.
I subscribe to your YouTube channel.
Good. Very good. Watch the videos.
I watch them all.
Isaiah, don't forget to send me my email. Huh?
I said I watched them all, I think.
Okay, great. Awesome. Take notes. Good job. That's what it's for. When you miss class, use YouTube to catch up. That's why I do it. Because I know sometimes we have to be gone somewhere or we can't get on. So I use YouTube so you can catch up on your work. So there's no excuse. Tomorrow's Wednesday. All I'm asking you to do is go into Acellus. That's everybody in Ms. Darby class. That's everybody in my class. And that's everybody in virtual. You have devices. Go into YouTube and not YouTube, my bad. Go into Acellus and complete math and science. That's all I ask you to do. That's all I ask you to do. Yes, sir.
Okay.
Acellus. You have Acellus, right?
That's not bad.
I made a mistake when I said YouTube. It's Acellus. I'll give you the link to the YouTube. If there's no more questions and we are good and we all on one accord, all minds and hearts are composed, are done for the day. We are done for the day. I enjoyed you very much. Enjoy your one day at the house, working diligently. Make sure keep this in your notes. Make sure you keep this in your notes.
She ain't ended yet.
What? What's wrong? Oh, you waiting on me to
To
end?
my grandma.
Okay. Well, I'm actually ending it. Y'all have a great afternoon. Love you. See you later. Thursday. If you need me, call me, text me.
Yes, ma'am.
All right. Bye-bye.